All right, so we had just explained to the class that you probably don't need to write the entire problem down. As long as you have the equation and your starting number and where you're going, you should be all right. Okay, do you want to work on these on your own first or together? Work on your own. Do you want me or us to set up the reaction first? Yes. Okay, we can certainly do that. Then I'll go ahead and hit pause after that. Okay, so if it's difficult to read, we got when oxygen combines with 8.20 moles of propane, which is this compound right here, in a combustion reaction. Even if we didn't go any further, I would hope that we know what are your byproducts in a combustion reaction. It tells you later on, but what would you know if it did not say that? Water is one, carbon dioxide is the other, okay? So how many moles of carbon dioxide are released and how many grams of water are produced? So we kind of put two of these problems together, so just gives us that much more practice. Anyway, propane, C3, H8, okay, combines with oxygen, okay. Let's not learn the hard way. Don't do just that. Okay, yes, we need to have O2, and you had correctly said your byproducts, carbon dioxide and water, okay. So then when oxygen combines with 8.20 moles of propane, so we got 8.20 moles of this substance, okay? How many moles of carbon dioxide are released? Okay? And then there's a part B, how many grams of that? Okay? So I will go ahead and hit pause, and you can work on that, and we'll go over it together in just a moment. Okay, so we're back, and first thing you're going to want to do is balance this reaction. And to help yourselves out, if this number is odd, is that any significance to you? Sure. I will loan you $50. No. I will loan you $1,000 at 100% interest. That comes back to me as what? $2,000. Yeah. If it's odd, you don't double it. If it's an alkane, so it's kind of maybe a little tricky because if we had C3H6, then you would double it. But that's more so of a upper level chemistry class. If it's this, we don't double it. We can just go ahead and jump right into this. Put a 3 there. Okay? Let's hold off on our oxygens. Carbons are done. How many hydrogens are here? And how many are over there? Okay? So what should we do? And then how many oxygens are over there? 10. And 10 divided by 2. Okay. So in this problem, we've got 8.20 moles of this substance. And again, if you wanted to abbreviate that, you could. So how do we get moles to cancel in our next step? And how many steps is this? That could help you out too. It's just a 2-step problem, so we really don't need to have this that long. So I'm going to leave it out there. So how do we cancel this on our next step? Okay, propane, and what are we looking for? We got to get to that side of the equation. Moles of CO2. Okay, so we see a mole over a mole. What does that tell you need to do? Go back to your equation. Is there anything in front of propane? No, we can leave that the same. Is there anything in front of CO2? So 8.2 times 3, and that would give you your answer in moles of carbon dioxide, which is what? 24 point mole of CO2. Okay? Two-step problems. Fairly straightforward, we hope. If it's a mole and it's asking for a mole, just 2 steps. The second part of this, how many grams of water are produced? So we don't need to start all the way over. We can still leave this here. Can we leave this here? Yes, we can. But that's got to change because we're asking for water now, not carbon dioxide. So here we will remove that. And what do we want to put up on top here? Okay, so we've got moles of H2O. Again, we've got a mole over a mole, which means what? Go back to your equation. This is still 1, but this is what?
4.
Okay. Then, what do we do in this final step?
Water at the bottom.
Okay.
Mass of H2O. So whatever that comes up to.
Again, this is one of them aspects we're going to say, you laugh if you want. Just human nature. Some people might do that. Why? Why might they do that? Because we're looking at this and saying, oh, well, that 4 is there. We must have to put this here. Again, you're going to answer your own question. When is the only time you put coefficients into these problems?
Second part as well.
If it's a mole over mole or a mole ratio. Okay? So now we're left with grams of water, and that's what we're looking for. So in this case, 8.2 times 4 times 18.02, and that gives you what? 591.06 grams of water. Okay? Make sure our mouth is shut when we're going down the road. On your pop the clutch. Do a wheelie. Don't do that. Okay. No, I haven't tried either because I think there's better things to do with our time than that. Because yes, those are. You need to respect those machines because they can be dangerous. And I know you do. Okay? Problems, questions on what we see up above? Rut row?
Yeah.
Is it presumption? We're good? Way over there. Second row. Third row. And third row. Okay. If you were to encounter this, is anyone just stuck with, I have no idea how to write this double replacement reaction? Okay? We need you to use the I don't mean vocabulary, but use what is given to you. And that is, if a chemist is reacting, that means this is on the left-hand side. If they're reacting lithium hydroxide, which is what? What's lithium symbol? Okay, and what is hydroxide? OH, okay? Do you want to balance out the compounds or just balance it out when we're done? mean, do you want to move on to the next reactant or balance this out first? It is balanced, yes, that's true. -1, +1. Okay, so we are reacting that with phosphoric acid, which is this, okay? So since that is given, this compound is already balanced. Is any of them subscripts going over to the right on the product side? Both of these, neither one of them, or what? Just the 4 does. And why is that? Significant, why? Well, when you say because it's phosphate, it's part of the formula. That's why. That's what I'm interpreting that you mean. So, even if you did not know what the charge of phosphate was, here we can figure that out because hydrogen has what charge? Plus what?
+1, so +3.
So then that would mean this is +3. We've only got one phosphate ion, so that means that's negative what?
3.
Okay? So the charges will not change from one side to the other. Do we have problems with finishing reactions? Because that's part of this too. Okay? So what is lithium going to bond to from this compound, but on this side of our product equation? Lithium and what? And you would know that one of two ways, either by looking at your reaction, or how else would you know it? And it just says that it says how many grams of lithium phosphate are produced. That would be another way. So, here we go. Charges do not change. Do we need to alter that?
Put a 3 in front of the lithium.
Put a 3 where? In front? Oh,
On
okay.
the right side of lithium.
Oh, okay.
Is that in front or behind of lithium?
Is what? The 3?
Well, say, if like I told you to put a 2 in front of lithium, would you put it on the left or the right side?
You put it on the right side. But if you're saying 2, then I don't know if you mean
No, I
a
was
subscript
giving you
or a
an example.
coefficient.
Exactly. I was giving you an example.
Okay? So then, but we haven't begun to balance it yet, though. Okay? So what's left over? Hydrogen and what? Which means we're going to, you can do this, H2O, or if you want to do hydroxide, you might say, well, we produced water up here. Why did we not write it as HOH?
Doesn't really matter.
Well, it doesn't matter for one, and we don't have a hydroxide ion over here. But you can write it again as H2O, or you can write it as water. Okay, so therefore, what about balancing these? Does it look fairly tough? Okay, well, let's start with our metals. You got 3 lithiums on the right. Okay, how do we get 3 lithiums over here?
About 3.
Okay, so our lithiums are balanced. Okay, how many hydroxides does that give us now? Okay, and how many hydroxides are over here? Just 1. So how do we get that up to a 3? Multiply by 3. Okay, so now we've got 1 phosphate and 1 phosphate, 3 lithiums, 3 lithiums, 3 hydroxides, 3 hydroxides, and then what's tricky about this is don't do this twice. What I mean is distribute this 3 here and say we've got 3 hydrogens here and 3 hydrogens here. Okay? If you make it hydroxide, make sure you keep it as hydroxide. Does that make sense? Okay? So then, how many hydrogens do we have? 3, and 3 times 1 gives you 3. Right? All right. So now, if you're reacting 3 3/4 moles of lithium hydroxide, 3.6 0.75 moles. Okay. And how many grams of lithium phosphate? There we go. Okay. Do you want to proceed on your own or work on this together? On your own. Okay. We'll go ahead and hit pause here, and you can work on it. All right, so we'll go ahead and get rolling again. We've got 3 3/4 moles of lithium hydroxide. How do we cancel this in our next step? Okay, so now we're going to go from this side of the equation to this side. Okay, so how many moles of lithium phosphate are there? There's just 1. Okay. We've got a mole over a mole, which means come back to your equation, and we need a 3 on the top or the bottom. Okay? It would be easy to make that mistake. Oh, we got a 3 there. I need to put a 3 here. No. That was composition stoichiometry. This is reaction type. Now, with this coefficient, goes here. These are now gone. We're in moles of lithium phosphate. We're getting closer to grams. So we put moles of lithium phosphate down here. And what is the atomic mass of lithium phosphate? Well, we've got, what, 31, 64. Is it a little over 100? Okay. 101. Okay. And remember, lithium phosphate is this entire compound here. 16 times 4, 32 times 1, and then I think this is 21. Lithium is 7 grams, I think. No, it's 4, I bet. Yes, I'm not sure. Yeah, it is 7. Okay. Okay. All right. So upon, I don't know if that's right.
115.
Okay. 115. All right. Okay. Then we're going to take 3.75 times 115. Then divide that by 3 and gives us 143.75. 143.75 grams lithium phosphate. Okay. And who knows with this whether they're going to cooperate or not. Chances are I don't know why we would be dismissed early tomorrow or not have school, but stranger things have happened. Of course, the next time that you're in this class, we've got your first evaluation. Rut row, anything we need to add? We're on the bus. Second row, we're on the bus here. And third row, we're on the bus here. All right. Yes?
Would it be a combination of moles to moles and moles to grams?
Yes. Or grams to moles. So it's either a 2-step problem or a 3-step problem. Okay. We'll catch up to you next time.